Hello there! My name is Florian and I welcome you to IT Tech Tips. In this two-part episode, we're going to talk about building our very own PC. In this part 1, we're talking about the theoretical background, so all the hardware matches together, and in the next video, part 2, we're actually building the hardware, assembling everything together and setting up the operating system. So let's dive into some important theoretical background. Let's have a look. So why should you build your own PC instead of just buying a pre-configured one? If you have specific needs, then you can build your own PC tailored to your specific needs. This is harder to do with buying a pre-configured system. For example, you might want to build a gaming system or a cheaper office PC or a multi-purpose multimedia machine, and building your own system enables you to choose the exact hardware for your needs. Usually, when you build your own system at the same budget, the same price, you get a better quality of hardware components because you don't have to have any margin for your time or for production facilities. Typically, your own build system is more future-proof than buying a pre-configured one, because if you use a mid-sized tower, you can easily swap out and replace hardware in a few years when your PC is too slow. For example, the graphics card is not up to speed for the most modern games anymore. This is harder to do with a pre-configured system, and sometimes you even lose warranty if you open the case. Last but not least, you will learn a lot when building your own system, and it's a lot of fun. There are some disadvantages though. Warranty handling with your own system is more complicated, because if something breaks, you have to find out yourself what broke and then replace this specific part of your PC. If you buy just a pre-built system, you can go to the supplier or to the manufacturer and just tell them that the whole system is broken, and they will have to figure out what's wrong and replace it if it's within warranty. With your own system, if something doesn't work, it's your fault. You are responsible and you have to figure it out. So it's a bit more complicated to operate your own built PC than just buying a pre-configured one. Last but not least, it takes some time to build your system. It takes time to pick the right hardware, to make sure it's compatible, to assemble everything, and to set up the operating system, install the driver, etc. But the good news is, it's much easier than 20 years ago. Modern operating systems usually bring a lot of drivers with it, so it's much less time consuming to build your system than it was 10 or 20 years ago. For an experienced builder, it's possible to assemble and set up the operating system, including all drivers, in under 2 hours. If you never built a PC before, I suggest that you take your time, for example, a whole weekend. Let's have a look at the whole process for building your own system from start to finish. First, you need to define the purpose of your system. For example, if it's a system for gaming, if it's an all-purpose machine, is it for rendering, for video editing, or just for office applications? Should the system be incredibly fast, or should it be absolutely quiet? These are all things which have to be considered before picking the hardware. Quite importantly, you should know your budget. For example, if you want to build your system for $500, that seriously limits your options. You will not be able to build a gaming PC for $500, but you will be able to build a simple office machine or just for learning purposes for $500. A good rule of thumb is, for a gaming PC, you should calculate about $2,000, for all-purpose multimedia machine, something around $1,000, and for a very simple setup, about $500. Then comes the most complicated part for a beginner. You have to evaluate the hardware and make sure that it's compatible to each other. I suggest that you first decide whether you want to build an AMD system or an Intel system. An AMD system at the same budget typically has more CPU cores than an Intel system, but each core runs a little slower. And an Intel system typically at the same budget has a lower amount of cores, but each core runs a little bit faster. So if you want to build a gaming system, which typically doesn't need more than 4 to 6 cores, I suggest that you go for an Intel system. If you're more into CPU applications which need a lot of CPU cores, like video rendering, with my software, some software also need the graphics card, or rendering 3D animations which often run on the CPU, I suggest that you go for an AMD system. Then you have to make sure that the mainboard is made for either AMD or Intel, and that the CPU you pick is for the right socket on the mainboard. In modern shops, usually you have filter options, so it's not that hard to find the right CPU for your mainboard. The same goes for the memory. You have to make sure that the memory, or RAM, or random access memory, it's all the same, it's different expressions, is compatible to your mainboard. Also here, please use the filter options of your preferred shop. If you're a complete beginner, I suggest that you consult a list. A lot of PC magazines contain lists of hardware which is compatible to each other to build a PC, and then you can modify the hardware a little bit if you know what you're doing and make the system more tailored to your needs. Or you can consult a friend of yours who has already built a system. Or you can watch a video like this one, in which a PC is built from the ground up, and hopefully in this video you get a list of parts as well. Well, the next step is easy but expensive. You have to actually buy the hardware. Then prepare a well-lit workplace and lay out all your tools you will need for building your system. A well-lit workplace is important so you can actually see what you're doing. I suggest that you also download all the drivers and the newest BIOS for your mainboard before building your system. It just makes your life easier. If you're into building all the hardware together, you don't want to go to another PC and having to download the stuff you forgot. Now comes the fun part, at least for me, the actual assembly of the hardware, which will be part of the next video. I suggest that you take your time when assembling the hardware together. Fixing mistakes can be pretty hard. For example, if you build together your whole system, boot it up for the first time, and then you recognize that the CPU cooler is not mounted correctly, you have to pretty much disassemble the whole system and reassemble it again, and you're probably even gonna break a part while doing it if you're a beginner. So take your time, read the instructions, watch this video a few times or the next video, and when you feel safe, start assembling, take your time, don't make any mistakes. When everything is assembled together, it's time to install the operating system and the drivers and updating your BIOS. I hope you will have a lot of fun building your system. Now let's have a closer look at some of the hardware components I've picked for my system, with a brief explanation why I've picked this hardware. First, there's the case. I picked a mid-sized tower case, so it's easier for me to show you how I built the system. If you pick a smaller case, this might look better on your desk, but it's going to be much harder to assemble the hardware together, and you will be much more limited with the selection of hardware you can actually use and which is compatible to the case. So for your first build or even your second build, I suggest that you go for a mid-sized tower and the standard ATX form. The case is not just for cosmetics, it's important to keep a nice airflow through the system. So typically a mid-sized tower has some intake fans in the front, which will intake the room temperature air in the system. Everything heats up and then it will get blown out at the back of the case. Then there's the power supply. That's easily explained. Your components need electricity and the power supply will provide that electricity. If you're building a gaming system, you should choose a 600 watt or even a bit higher power supply. If you're building an office system, a 400 watt power supply will supply plenty of power. Also make sure that you pick at least an 80 plus bronze power supply. This is a quality rating. In my system I even picked a 80 plus gold supply, which are a bit more expensive, but if the system runs idle, so not consuming a lot of electricity, the higher the rating, the lower the power consumption. Then there's the CPU, the Central Processing Unit. Everything you do on your PC will need a CPU one way or the other. So this is one of the key components and also one of the key price drivers of your system. If you're building a gaming system, you will need a CPU which has a lot of speed per core. So at the same budget, you rather take a CPU with less cores, 4 to 8, but high speed per core. If you're building, on the other hand, a rendering or video editing system, I suggest that you use a CPU with many cores, but at the same budget, each core may be a little bit slower. In my case, I've picked the AMD 3900X CPU, which has 12 cores and is not overly expensive. It was around $400 at the end of the year 2020. So with this 12 cores and hyper-threading, I actually get 24 cores for my software and it runs pretty good. Then there's the random access memory, or short RAM, or just memory. Make sure it's compatible to your mainboard. Another thing to consider, if you need, for example, 16 GB of RAM, it's better to pick 2 times 8 GB of RAM, because this will run faster than 1 time 16 GB of RAM. If you need 32 GB of RAM, I suggest you take either 4 times 8 GB of RAM if your mainboard has 4 slots, or 2 times 16 GB of RAM. This is cheaper and faster. If you're building a gaming system, I suggest that you take about 16 GB of RAM at the end of the year 2020. This will be a bit more in the future, of course. If you're building a higher end rendering system or do some virtualization on your PC, I suggest that you go for 32 or even 64 GB of RAM. If you're building a really simple office system, 8 GB of RAM will be enough at the end of the year 2020. Then there's the GPU. You can invest a lot of money in a GPU to get higher performance. Some mainboards and CPUs have integrated GPUs. If you're building a simple office system, the mainboard and CPU graphics output will be sufficient for you. If you want to play a little game from time to time, or if you're building an all-purpose PC, I suggest that you take a mid-range or lower mid-range GPU for between $200 and $300. At the moment, it doesn't really matter whether you pick a AMD Radeon or an NVIDIA GeForce GPU. They provide about the same performance at the same price level. For a gaming PC, I suggest that you go for a higher-end GPU, and you have to invest around $500 just for the GPU. Then you have to store your data in some way permanently. For that, nowadays we're going to use an SSD. The typical form factor of an SSD, so it's physically compatible to the mainboard, is M2.8820. That means it has a width of 20 mm and a length of 80 mm, so it's 80-80-20. The SSD comes in 2 options. There's the cheaper option, which is a SATA SSD, which has a top speed of typically 500 megabytes per second. It cannot run faster because of the interface, which limits the speed of the SSD. And there's the NVMe SSD, which has a PCI Express interface, which is much faster, but also a bit more expensive. Since my mainboard doesn't have a Wi-Fi connectivity, I put in a Wi-Fi card so I can connect to my home network by Wi-Fi. And then of course there's the mainboard. The mainboard connects everything together. So the mainboard should have the right form factor, which is the size for your case. I suggest that you use a ATX mainboard and the ATX case, and you will have no problems with compatibility and form factors of the hardware you put in. And as I've mentioned in the beginning of the video, it's important to have a good, well-lit, prepared workplace. with an anti-static mat, so you don't discharge electricity from your body to the hardware components because they are really sensitive to that and they will break. And you need a set of screwdrivers. I personally use the iFixit Protect tooltip, which goes for around $70. And some Velcro tape for tying the cables together. This is called cable management. Cable management also is not just cosmetics, because if you have the cables tied together nicely, it will improve the airflow through your case. And modern CPUs throttle down in speed if they get too hot, so when tying the cables nicely together, you improve the airflow, you keep the system cooler, and the CPU therefore runs faster and the system stays a bit more quiet. So that you don't have to watch this over and over again, I put together a list of the components I used for my system down in the description. My system has the purpose for video editing and rendering 3D animations, and I will play from time to time on it if I get to it at the weekends. So I have a mid-range graphics card, a higher end CPU. I used 64 GB of RAM because rendering uses a lot of RAM, and I also do a lot of PC virtualization, also for recording videos for this YouTube channel. And I've chosen a fast SSD storage device because I don't want to wait for loading screens in games. Alright, I hope you got a lot of valuable information out of these videos. If you did, please click the like button. If you have any additional questions to what I've told you in this video, please leave a comment down in the comment section. And if you don't want to miss the next episode when we are actually assembling all the hardware together, please subscribe to the channel and ring the bell. Stay tuned, see you next time.